Thank you, and thank you for inviting me to the KMI Stadium. It's quite interesting to sort of be talking in a slightly disembodied way where there's cameras around the room that are all probably recording and broadcasting me God knows where. So if I look slightly distracted and I'm looking in the wrong place, it's normal, it's just my lack of experience. Hi, thank you for the sort of detail about the Cisco Academy. I think it's a little bit more than what people are aware of. I am, as Alex said, working at the Open University now for about 6.5 years, but I've been involved with the OU since about 2003, getting the Cisco modules into our teaching at the Open University. But what's quite interesting about the Cisco Academy program is it's not a new thing. It's been around for about 16 years now, and because of that they've got a massive community out there all learning infrastructure networking. What I'm going to do during this session is talk about the challenges we face in network engineering of pedagogical and simulation modeling technologies, and how we have to overcome many practical problems involving Cisco networking equipment and the cost that a school or a college in a developing nation or in a small town in the United Kingdom has to face when trying to teach this type of network technology to networking engineers that are going to be our next generation and our 16-year-olds of today's. Bit of background. Most people have heard of Cisco but don't know who they are. They're probably one of the largest companies in the world when you consider the likes of Apple, Oracle and Microsoft. The chances are you're connecting to me now, you're seeing me now, whether it's on the YouTube recording or via the live broadcast via Cisco networking equipment. Basically, they make routing, switching, telephony, security and firewall equipment that runs this little worldwide thing called the Internet. There are a couple of other competitors out there, but Cisco has very strong market dominance, mainly because their equipment is very, 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 very reliable, mainly because they created this academy program to train young people and to maintain their presence in the marketplace as well. So I'm looking around the Open University, you will find Cisco wireless access points, probably where you're connected at the moment. Your service provider is connecting using Cisco high-end equipment that's probably costing a few $1 million to actually run this connection at the moment. Cisco, in about 1998, created their NetAcad program. It's gone through many iterations over many years, but in straightforward terms, it's an educational program. It's a free educational program that enables schools, colleges, universities, other partners, there's prisons, there's community development projects out there, teach people how to become network engineers. Some go all the way, some will use it as an introduction to networking. Whatever way, it's very good. There is about 1 million students at this precise moment studying some form of Cisco networking, but over the 15 years they've easily reached 10 to 15 million individuals in over 160 countries worldwide, with the United Kingdom being one of the earlier adopters within the Academy program, and us having around 33,000 down to 27,000 students precisely at this moment studying Cisco, whether it's part of their degree or qualifications like the BTEC National or qualifications from City and Guilds and OCR. So it's quite pervasive. There's a local college near this building that's doing it with their 16-year-old students, I'm aware, as we speak. So we use their academy program as part of our assessment in the Open University. We have modules like T216 that has at this precise moment 400 students studying on it, and we've had a large number of students over the years. I think we lost count after 5,000 doing this type of study. We also offer it postgraduate, so we have the professional level as well, which means that we have students that are going out to become high-end network engineers, whether it's for a large company, for a local authority, for the university, or for defence services, because this technology is used in defence communications as well. What is important to understand about NetAcad is it's very practical, it's very hands-on, it has a very specific pedagogy. Whilst there is a lot of knowledge and there's a lot of information that has to be absorbed and understood, and a large number of networking and infrastructure concepts, whether it's IP networking or routing technologies, it is all about getting the student, the individual, to be able to configure, manage and maintain the technology. If you don't get your hands on a network router, in this profession you are considered to know nothing. It's a bit like being a programmer but only knowing the concepts. Here in networking, you've got to be an engineer, you've got to know how to configure the router, and more often than not you've got to know all the right swear words when it goes wrong, because we're engineers after all. But with the use of live networking equipment and the use of remote labs, the challenge is it's very equipment and very cost intensive. We use what's called entry-level routers. An entry-level router in our world is anything between 800 to over £1,000. It's not a home router. These routers will handle 2,000 connections in one go, and will handle probably this whole building that I'm sitting in, which is about 4 floors high, and probably has about 400 or 500 people occupying it at any given moment. So our students, our networking students, have got to be able to configure this level of technology. So to set up a basic Cisco lab for an absolute startup academy costs £5,000. It may not sound a great deal, but education in a cash-strapped economy, £5,000 is £5,000 more than they don't already have. So Cisco helped solve this problem by creating their own pedagogical simulator. It does everything that the Cisco networking equipment does, but in a sort of hands-on yet detached environment, where they created an application called Packet Tracer, and it enables the students to go read the curriculum, and then at a certain point when it's go and do something, they click on a link that downloads a file that opens up the application. Then they can actually carry out the material, the content, the learning they've done. So it's very much about learning, then doing, then learning, then doing, and then you get the pattern. It's all learning and doing. And the doing stuff will backtrack to all the learning stuff, but the learning stuff has informed how they are going to do what they do. So each time they come up with a slightly different scenario, a slightly more complex challenge, but something that is relevant to the technologies, where it could be simple IP addressing or getting 2 personal computers to talk to each other, up to solving redistribution problems between 2 converged routing protocols, which is a normal challenge that a network engineer would have to face. And by building this pedagogical networking simulator, they cover all of their associate and associate security and some of their professional level. So in the worldwide Cisco Academy, out of that 1 million students at this precise moment, around 750 to 800,000 of them could study everything using Packet Tracer, but also they're still encouraged to get their hands on the live equipment and discover the differences that go on with real technology as well. Some of you may have played Need for Speed. Some of you may play on a games console. Need for Speed's fun, but doesn't make you a car driver. And that is the challenge in networking as well. Using Packet Tracer is fun, and it will get you to a stage where you understand many of the dynamics of networking, but you still need to go and touch the tin, as we say, and actually get your hands on the real equipment as well. So we've worked with this very much as the first step technology within the Open University, that we have all of our students studying using the simulator, but they still must go and do day schools, and in the day schools all they touch is real Cisco equipment, so that they've had all the practice, and then they're able to apply it in context and actually then drive the car, so to speak. But we couldn't have afforded for them to have 600 hours of pure car driving or pure networking equipment, and that way then they can actually go away and try and try and try and try again. And the nice thing about a simulator, which we don't like with cars, is they can crash it as many times as they like, and they can learn all the different ways of crashing it and seeing how it goes wrong, totally safe in the knowledge that they can then restart it. So packet tracer, I mean, this is a graphic of one of the networks we're going to be looking at shortly. It's all very straightforward technology. The graphics look like the symbols that look like the technology. It uses network and engineering conventions, so the icons you see look like the icons we would see in a network design topology diagram. The little green and red lights are meaningful as well. The green lights on the right means the connection's up. The red lights on the left mean the connection's not up yet. If you actually look at live networking equipment, if you look at the back of your PC at the network interface card, we also use those LEDs. So it is for real, it is emulating real engineering practice. So if the light is orange, it's negotiating. Your PC does do that, you just don't ever bother to look at it. And nobody reaches around the back of their PC to see that. But if you actually go into a server room with all the flashing and blinking lights, you will see some of these things taking place, and so will these networking students as well on live equipment. And they can actually build up reasonably complex topologies. There's a dotted line between my router and another router. That is a crossover cable. The black line is a straight cable, and the lightning bolt cables are WAN serial links, wide area network serial connections, just like a real network structure. There's fiber connections, console connections, wireless connections, and they all behave in a very, very similar way to the real technology. The beauty is, one of those WAN connections will cost quite a few £1,000s to install. That one is free. Those routers in there, that's already £4,000 worth of routing technology and another £1,000 for a switch. It's free. So the student can actually save money, well, they're not spending it in the first place, but actually get access to the technology that's simulating the real technology in a way that they can build actually very, very, very complex, millions of pounds worth of networks. And there's competitions out there on Facebook where they encourage students to do that with all the network convergence, but it's free, and it actually downloads into an XML based file that is kilobytes in size. So it's free and incredibly low storage and an incredibly low memory use and incredibly bandwidth non-intensive as well. And you see on the right hand side there's personal computers, PCs. There's a little console, a command line in them. You can set up the IP addressing in them. There's a little web browser in them as well, which we will be able to quickly look at, which means that you can actually get them to engage with other technologies with none of the network security problems as well. So the other nice thing is we can get the students to do naughty things, we can get them to do security problems, but in a safe, contained environment. So they get all the relevant experience without committing crimes that are a criminal offence under the Computer Misuse Act, for example. So in that respect, we're, as geeks, quite impressed with this. What I'm showing you there is just a config that I pulled straight from a packet tracer router. If you're a network engineer, you will understand how the OSPF, Open Shortest Path First Routing Protocol configuration works. The beauty of this is I can copy and paste that straight from my packet tracer router, put it in a notepad document, wander over to my live real router and put it in via copy and paste, via a TerraTerm or hyperterminal session. So the reality is there is actually integration between the artificial, the simulation, and the real as well. That anything a student or an engineer does in this environment can be picked out and dropped straight into a real environment as well, using practices that are normal in network engineering. In fact, they can use many of the sort of different operating system commands that you would find on a real router. I've just done a show IP route command here on a simulated router. You wouldn't know that it's simulated. That could have come straight from a real router. The output is exactly the same. In fact, there has been discussions whether we should start doing a Turing test with the simulator and create a black box environment where we could actually get two students into a room at the same time with two different boxes and ask, is it real? Because I think we've got to a stage now where we could trick people with simulated routing technology and actually deceive them into thinking that they're working on real networking equipment. And yeah, it would take a very, very, very experienced engineer, maybe, without the fact that I've already tipped them off, it would take them a long time to work out if that is really real or not. So we've come a long way from the older simulators that just gave an idea or just gave a sort of basically a statistical update that told us that this is something that's behaving on a simulated network environment. So what we'll do is we'll actually have a look at packet tracer in action. So just bear with me as I escape out of one application and go straight into my virtual machine. So, as if just by magic, up pops an instance of packet tracer, and I will just go inside my virtual machine. Packet tracer is designed that you can build and build and build and build. It's also designed to be intuitive. We find that our students only take maybe an hour or so to become familiar with the technology through experience. And so much of it you can actually just sort of go into the device, click on the device, and if it actually just pops a window, nothing special about that. But what we like about it is the first window, the physical window, means that we have a reconfigurable router. Now I'm actually going to get up. Now I don't know if the cameras will track me. I mean, for the benefit of the recording, there's an on-off switch there. We like the on-off switch. You can switch that off. I'm not going to, and I can actually select from the bank here all the different interface cards and drag them, plug them in, and switch it back on again. That is a real engineering practice. So you have the different networking cards. You're not going to put it in while the router's running live. It tends to go bang. And it emulates that simple, practical, but essential skill. And I can actually add all kinds of interfaces. So if that's already £1,000 worth of equipment, here is another few £1,000 worth of specialist fibre, Ethernet, wireless and async technologies, which are again very meaningful to network engineers. On the PC we've got the same things. We can switch off the PC, change its card from wireless to physical. The servers have got similar interfaces as well. And the beauty of that is then we're not saying that there is one specific device. We're saying that this is a very adaptable device, which is a norm for network engineering. The config, we can actually add, remove different sort of configurations directly. We can name the device, but the most important thing is this window here, the CLI or command line interface. This is 1970s technology today. A lot of people think that everything is gone very much down the GUI, the graphical user interface. Network engineers hate GUIs. We do not do GUIs. GUIs are a massive memory overhead that we do not want. And when we're doing distant telnet sessions, it's all about getting inside the command line and actually being able to configure the router as if it's the real device. I've got a small audience here. How many of you have used Unix or Linux? That's good, the majority. I'm in safe hands then. Okay, that's good. If you've used Unix or Linux or a little bit of experience with DOS or the command line in Windows, this is the same kind of world. And in this simulated router, we have a command set. And if you went to a real router, you would have the same command set. In fact, I can actually just show the running config. And again, this is meaningful to the networking geeks. This looks like a real configuration inside a real router. And you can see in the bottom right hand side of that window, copy and paste, because I can copy out of here and put this onto a real router. And even more frightening, I can go to a real router and copy and paste its config into Packet Tracer as well. Normally there might be a tiny bit of editing, just like we would edit programming language code. But that's normal. We might have slightly different interfaces. That's normal. That is professional practice. But the reality is now, I can show, and I'm just going to show the IP route, and I can actually see that this is set up, this is connected. It's not seeing any other networks at the moment, but it's seeing the free connected local networks. And I know there's free connected local networks either by looking at that, or I can see from this side of my topology, I've got 2 cables and I've got a loop back. So that's created my free networks as well. I can actually go inside the PC, and it is quite useful to do that. Again, the physical, oh look, on-off switch, yeah? Have you switched it off and on again? It's an important skill, and if no network engineers learned to do that, then they're stuck. Importantly, we can change all the network cards, and we can actually reconfigure this pseudo PC device. And no, is it a PC with an operating system? No. Is it a PC that carries out certain operating system tasks for networking? Yes, because in the desktop environment, you can see we've got IP configuration, we've got terminal emulation, we've got command prompt, we've got web browser, VPN, we've got a traffic generator from this PC, so we can do pings, HTTP traffic or FTP traffic. It can send emails and so much, because we've actually got web servers, FTP servers, and email servers and DNS servers in this environment as well. And the nice thing is I can easily go into the command prompt now. I can appreciate that's not showing up too well, and I can just bang in the IP config command, and it works. I can run ping and it will work, and I can run traceroute, and cunningly it works. In fact, there is a very limited feature set of DOS type commands, but the ones that you would use when learning to build a network, and even when we're professionals and experienced, the kind of commands that you would apply daily without thinking about it. So at the moment I can see the default gateway is 155.0.0.1, so if I ping 155.0.0.1, and yeah, as luck would have it, because I did configure it properly and I did check it, it works. So we're now enabling students to do that from the safety of their own home using their own technology. And some network engineers get quite upset when you start pinging them. They usually block ICMP traffic, and they're quite suspicious if there's pings flying around their systems. And here they can do it quite safe. It's sitting inside the emulation, and we can actually do quite a range of sort of different network structures. So you are purely limited to only your imagination. Down the bottom we can add different switches, wireless devices, different kinds of PCs, cloud technologies and routers. Whilst they are, I appreciate, all Cisco based, because Cisco's created this, the really nice thing about this is all the technologies they use could be used in any other networking environments. If you learn to configure OSPF here, you can go and apply it on a Juniper or Avaya network, or a HP switch and so on. So it's not about just learning Cisco technology, it's Cisco sponsoring that you are learning networking, but obviously using their preferred environment. So simple yet powerful. So going back to the presentation, so just bear with me as I sort of jump the screens and let the thing flicker for a moment. And that doesn't like that, does it? It's decided to have a tantrum. Oh, that's good. Microsoft PowerPoint has just crashed on me. Bear with me a second and I will. No, I don't want to update. It's good that this is being recorded so we can actually see a Microsoft product succeed on a Mac. Right, apologies for that. I'm just going to flick very quickly forward. There you go. Now, the other powerful thing about Packet Tracer is I could now build this massive network. So sitting on my PC in my dungeon somewhere, quite happy, I can build this complex network. You could be somewhere else on the planet or in the same dungeon. Let's call it a classroom. And you could build your own network as well. Well, in network engineering, that's been going on for a very, very long time, since the 1960s. I build a network, you build a network. But one of the biggest challenges in network engineering, and it still exists, is what if we are to connect those two networks together? Most organizations call it a merger or a takeover. So we've now got network A and network B. We do not go and buy all new equipment for another network. We bridge between them and we make those connections. And the internet is designed just like that we continually add at the edge and keep expanding at the edge and expanding more technology on here. So we can actually build our own network. I could, as an educator, build a network, and I can have all my students connecting on the edge. Or as a student, I could build a network and my friend, my classmate, could build another network, and we can interconnect them. And what Cisco released was the multi-user technology. Basically, they've created their own wrapper protocol called PTMP, Packet Tracer Multi-User Protocol, which enables multiple instances of Packet Tracer to act as clients and servers. So I could create one complex network, you could create another complex network, and we can now get them to talk to each other. And what's the really nice thing about this entire structure is it doesn't send every packet. So it sends state change data, not pure protocol data. Now, why would that be useful? Well, I could teach my students on how to do a denial of service attack so they can defend it. Sending 10,000 packets across your WAN or LAN will upset all network managers. A few people are smiling. They get quite emotional about it, and some people can't think why. But what Packet Tracer does, it says, right, I am 10,000 pings. The other end goes, thank you. You're sending me 10,000 pings. I will now act like I'm getting 10,000 pings. So you sort of send one message on saying, I am now going to drub you, and the other end says, I will now receive your drubbing and drub myself. But in technology terms, that's beautiful. We do need to teach our network engineers how to manage that, and we need to teach them quality of service management as well, and high-end data rates without hurting our real networks. So this protocol just sends along, right, I am now in this packet, I've got this, and this, I'm an EIGRP up that, and by the way, there's 10,000 pings as well. The other one goes, thank you, I will now behave like I've got all of that. They're still talking to each other, but they're not sending every single packet of information like a real network would. because we want to emulate behaviors, not actually act like the real thing, because we could actually cause serious networking problems if we build a system more complex than the actual network it's being run on, which is the potential of packet tracer. So myself and individuals from the United States and within other members within the Cisco Academy program have been working on the concept of a simulated internet on the internet, and I'll talk a little bit more about that shortly. But the beauty of that is then we can create an environment, a playground, an intellectual playground, where students and other individuals can go and try out things knowing that they can't break anything, and if they do, they haven't broken the real internet. Because the reality is, if we let engineers loose on the real internet, people get very upset, and there's 3-letter agencies that will come knocking on your door at 5 a.m. So it's a playground, a safe place where they can build multiple complex different systems and actually have the experience of hopefully getting it wrong. Now the nice thing about that is then I can demonstrate it here, is I can actually show you that it's actually quite simple. He says now waiting, he's probably going to crash packet tracer again in a second, but that's all right. Right, so going back to my network here, what I've done is I've actually created a multi-user connection between these two instances of packet tracer. Now, this is the bit where you've got to sort of suspend disbelief for a while. Obviously, this is going to connect via a local loopback connection to here. So it's using 127.0.0.1. It's on the same device. But if you've got an IP address and you've got port 38,000 open, you could actually do this across a network or across any distance whatsoever. You can create a domain name and attach it to a domain name and so on. But for the purposes of demonstration, because it's visually simple, we've got two instances that could be on different sides of the planet. So I'm just going to connect. You can just about see I've got localhost and I've got port 38,001, and I've cunningly called it client, and you can set up a private password. The default here is surprisingly Cisco, so that's what we use. It works. But as soon as I connect, you can see this has made a connection over to here. Okay, so now that cable that's running from the client router is going through to that cable that's connecting on the master switch, the switch Terra Nor. So what we should see very quickly within the routers is if we just sit and wait, this is going to be a little bit of patience and a little bit of emotion. So if I just type in enable and then show IP route, at the moment it sees itself. Now that little line that's come up there has showed that there is a neighbor change in the EIGRP routing protocol, which means it's now discovered something. Network routers send hello packets. Okay, and if there is a reply, it will then make an update to its routing database. Hello. And it's been doing hello all the time that we've been sitting here, and then somebody said hello and it's replied. So we've now got, and it will go through an algorithm and it will decide what is it a valid connection, so on. It's made those decisions because I've set it up properly, I hope. But if I now do show IP route, you can just about see there's a slight difference. There was 3 entries before, there are now 4 entries, and one of them, if you can just about make out, CDCC. C is directly connected, D is EIGRP. So it's learnt a distant network via the EIGRP routing protocol. So in networking terms now, whoever was sitting on that computer on the left-hand side and cannot see the computer on the right-hand side has now learnt via this multi-user connection a distant network. It can see all the way through to the PC at the far end. So if I actually look at this PC, I can see it's got an IP address of 99.0.0.2, an easy to remember IP address. So I should be able to sit inside here and then type in ping 99.0.0.2. Again, it's always a tense moment. Dot, exclamation mark. Now, for the audience, you've got to believe me. That dot means there's a dropped packet. That exclamation mark means connected, reply, connected, reply, connected, reply, connected, reply. Okay? That's how Cisco. Why a dropped packet at the start? It's doing an ARP negotiation, address resolution protocol. It will drop a packet. It doesn't for real. Actually, packet tracers deliberately programmed to behave like that. So it will deliberately drop the packet as if it's trying to locally find that packet first. Then it manages to find it via a default gateway. And it's just, there's also a time to live element as well. So these two PCs that are far away from each other should now be able to see each other from afar as well. So ping, oops, sorry, I just typed in ping twice, 99.0.0.2. There you go, because the router has made that connection, you can see it's replying. So this PC, as we established earlier, is on the 155 network, and it can see all the way across into the next instance of packet tracer that could be somewhere else on the planet and see that remote network. Just like real networking, just like real network engineering. So now we can get students in a classroom, around 20 computers all doing peer-to-peer or hub and spoke or client and server constructs, and we can actually get them to build. We could build a simulated internet core, which was one of the earlier diagrams I've showed you, and actually get communities of students or communities of universities and colleges all connected together in this simulated internet, building up their pedagogical practice. So I'm going to go back to to PowerPoint now, and hopefully it won't crash this time, but you never know. So, tense moment. Will it crash again? Struggling? Yeah, it's crashed. It's quite reliable, this, isn't it? This is a good time to invest in shares in Microsoft. It's frightening how it sort of disappears for a moment. It really has crashed. Okay, I'm going to use a bit more of a common sense approach here and just maximize that screen and display it like that. I'm sorry, but you'll see some of my notes and underlines and so on, because I think that's okay. Overcoming the technological moment that we had there. I've discussed this already. Why do we want to simulate networking? I work in a field that actually hates simulation. It's all about getting your hands on the real technology. But the reality is it's a thing we don't want people to do in professional practice. We want them to be able to try it out on simulation and actually develop and make the mistakes. And the reality also is I have 400 students, some of them are working in the industry, and they go and learn something really clever from us, and then they nip off and try it on their live network. I'm sure they'll walk out with black eyes very quickly from the violence their colleagues will visit upon them, because that is just not a thing they can do. Whereas here in Packet Tracer, they can try, make mistakes, practice, develop ideas, and build up that initial experience. They can overcome the costs, they can overcome kit location issues as well. Also, the beauty of this simulated environment now is we've got a very highly scalable solution. We could, and I know this is part of the research that KMI is doing, develop a whole series of tablets or other devices that could all build their own virtual internet. So I could have a classroom or a community of students all with a device, all with one edge of a very large network that's now acting as part of a community networking challenge. So I can build a server or a mesh of servers out there with all sorts of individuals connecting into them and learning about simulation, learning about networking, but learning how to develop their professional practice as well. Because here now I can have a 16-year-old or a 20-year-old or an experienced network engineer, all trying things out in the safe knowledge that the worst they'll do is they have to restart it. Unlike the PowerPoint experience I've got here, they will make mistakes. They will crash it, but they're not crashing anything that we particularly care about. And they can add, remove, replace, upgrade, update, try, test, challenge, observe all sorts of different network behaviors taking place. And it's not about simulating a network to observe the network behavior, it's simulating a network to learn how to build networking technologies and build that professional practice. And the beauty also is we can keep adding at the edges. So I can build another server and another group of iPads maybe, or I can build another community in the United Kingdom. I could build a community somewhere else on the planet, and they can have their own simulated internets, and we can connect the simulated internets. So then the USA can challenge the UK can challenge Sri Lanka can challenge Australia, and we can have a worldwide mesh. So with 1 million students already using this platform actively, and even many more million alumni having access to this, we could actually sort of go around the world and build this community of simulated internet users and hopefully abusers. And yes, we've done work on this in the UK, we've worked with the USA, and there are others working on this in South America as well. So this is not a new idea anymore, it's just not an idea that's yet taken traction in the pedagogical space of teaching. So we could I could eventually build a scenario with some of the work that's going on that you could be sitting on your iPad, I could be sitting on my PC or web browser, and we're all connecting to each other via this simulated network in a risk-free world where we can just encourage anybody to develop practice, whether it's somebody doing it for the first time or an experienced network engineer that's just trying out that new, as yet unlearned skill. So we dwell in possibilities. There are many possibilities here, and I think some of the stuff that we've done will only sort of touch the iceberg of what might be available in pedagogical simulation. Now at this point, I'm happy to take questions from the floor, or if anybody who is following this online or will see the YouTube video, I exist on Twitter. I did put my Twitter ID up earlier, and I'm at Teraknor, and if you're really geeky, you'll know what that means. Thank you very much. Now we're at the end of the recording. John stayed awake all the way through this, which I'm quite impressed by, because he's heard this already. And that's also how to get 10 minutes into 45 minutes. Okay, seriously, any questions? Or coffee time? Hello.
Hi, thanks. I was just thinking about the simulator. Has there been any studies to try and identify, for example, some common mistakes that the students would make when they're using the
Yes, I think
to kind of improve the course material?
Yes, they have done, and they've actually done troubleshooting scenario, how people solve problems use it as well. And they can get back all kinds of metrics from this. What they do in their embedded curriculum is they're called PKAs, packet tracer activities, and they can actually get it to report back and actually track even all the commands they type in as well. But there are ethics issues as well as sheer volume of data problems. So I know they've done some work in controlled situations, but they've got actually a beautiful challenge, which is they've got so much data here available, but the ethics problems of they could be accused of being Facebook at the moment.
Yeah, I guess there are some things maybe are more privacy than others.
It's just
in terms of the networks that they are creating themselves.
If you could easily with this create a scenario where you say, right, you've got 3 or 4 steps to carry out, and then you track how they do it. and you could even set traps for them as well. And sometimes in networking, it's an argument: is it a mistake, or were they just trying to? Were they going for a sort of different systematic troubleshoot? But how many steps did it take? You could even say how many commands did they type in before it worked. And that might not be a measure of mistakes, but it might be a measure of how many iterations did they go through to get to the final path of success. But that might have only taken 3 commands, but they took 50. So it's a bit like programming. There's lots of different ways of doing something. It doesn't mean it's a mistake if you've done it a different way, even though it might have taken 20 commands when somebody else could have done it in 4. But what would be interesting is how many steps did they go through? How many times did they type, show IP route or show run or show IP interface brief before they actually worked out that the problem was putting the cable back in the hole at the other end?
So I guess if you're using a simulator, you're much more kind of encouraged than you can explore. Try out a few things rather than if you're using the real thing, you'd be scared of messing about it. So you just want to go straight to what you know would work.
Yeah, and I mean, I've taught this when I originally started teaching this technology in the late 90s, early noughties. It was all about hands-on, and it was very much you had to get the students on the routers. It still is, but we never had that safety net technology. And the students are encouraged to explore there. I mean, the worst that can happen is damage the operating system, but then they're also taught how to put it back on again, usually whilst you're glaring at them. So they get that's not, as far as we're concerned, that's not a bad experience. We want them to break it, and some of them get lucky and do wipe the operating system, and then we whip out this special exercise on, you want this one, don't you? Putting it back on. Some of them forget their passwords, and because they've just typed, any old thing, and then we give them the password recovery exercise. So it's all good experience, just some students are better at discovering those good experiences. Any other questions? Alex?
I've got one. So Cisco's Networking Academy is a very successful initiative worldwide.
I would say so, yeah.
What do you think the Open University or any other higher education institution could learn from the educational practices of the Networking Academy?
That is a very big and a very controversial question. Thank you very much, Alex. And I hope this is being recorded. I'm going to just pick on us because I think it's fair, to turn the lens back on myself. It's been a great experience working with the OU over the years, firstly on the outside to get it in, and then on the inside keeping it going. And what we've learned is how hands-on so-called skills are actually a very important part of industrial learning in networking, and the cognitive skills don't not fit with our norms of academia. So you ask the question, what can we learn? That this hands-on is an essential part of sort of engineering and computing practice, and doesn't detract from some of our more academic goals as well. It is just very focused on problem solving and getting things to work using very specific technologies and standards. And with that, the benefit I've seen is we are getting students that are able to go out and get industrially recognized skills. And I'm sorry to say, for us and many universities around the world, there is the issue that we could create just another computing degree. And how do we discriminate and distinguish and set our students apart? And one of the ways is by some of the commercial certifications they can walk out with. So our students at the Open University could get a CCNA Security or a CCNP, and for some that is greater value than the degree itself. not disparaging our degrees, it's what the industry wants and it's what sets them up for their careers. And we are about educating, developing, informing, but we are also about creating individuals that can be viable in the modern workforce as well. But then I'm biased about that. Any more questions? You can stop the recording.
Okay.
Thank you very much. You've been a lovely audience.